Today, let's make a movie recommendation system using Python. I'm tired of watching amazing movies and then not knowing what to watch next. I am sure there is something on Google that could help me with that, but it's a lot more interesting to make it ourselves. We are going to be using a movie database that contains information about the genre, the cast, the directors of thousands of movies, and we're going to be using that to help us make this movie recommendation bot. So with that, let's get started. First, we need to import a Python library that'll help us store and manage all of our data. We're going to be importing pandas to do that job. Then let's import NumPy, and then from the sklearn library, we need to be importing the count vectorizer method. Also from the sklearn library, we need to be importing the cosine similarity method. Both of those will help us compare the similarity of movies. Then we also need to be importing the difflib library. So let's get started. We'll first make a data frame equal to pandas.readcsv, and we'll be passing in our moviedata.csv file. We actually need to make a list of features that'll be used to calculate the similarity. So in our CSV file, we have columns for genres, cast, the director, the tagline, and then the keywords. So all of those features will help us establish a similarity score. Next, we need to make sure that none of the slots in our data frame have null values. So we'll be making a for loop, and we'll be iterating through all of our data frame features and making sure that none of them have null values by filling it in with an empty string. Now let's make a function called combine features. We need to combine all 5 features into one column. It'll make it a lot easier to manage and manipulate our data. So we'll be passing in a row, and we need to return a long string with all of those features. So we'll be returning genres plus a space, and then we'll be doing the same thing with casts. We need to be adding a space there, forgot a plus mark, and then the same thing with director, and then the same thing with tagline, and then lastly, the same thing with the keywords. Then we can accept, and we might just do a print with an error, and then the row that's giving us trouble. Perfect. So now let's actually make our data frame combined features column. So we'll call it data frame. We'll make a new column called combined features, and we'll do data frame.apply. We will apply the combined features function that we just made along axis equal to 1, which just means that for every row in our data frame, we'll be applying this combined features function. So now let's ask the user for the movie that they want recommendations based on. So that could be their favorite movie or the movie they just watched. So we'll be asking for an input. We might ask for a favorite movie, and we'll be storing that in user movie. So the user will type in a movie and store it in this variable. However, it's not incredibly efficient to be searching through our database with a super long string. Instead, we want to find the index for that movie. Each movie in this database has an index, so an index of 0 will correspond with the movie avatar. And we want to be finding this index for the movie that the user puts in. So in order to do that, let's make a helper function called index from title. We'll be passing in a title and returning an index. But let's add another feature here. Just in case the user misspells their title or doesn't type the full title, we don't want our program to throw an error. So this is where we'll be using difflib. So let's first make a list of all of the movie names in our data frame. So we'll make a variable called title list, and we'll do data frame title, and we'll call the toList method. Then we can set the title sim variable, the title that's most similar to that which the user put in, and we will be calling difflib.getCloseMatches. We'll be passing through our title. We'll be looking on the title list, and we'll return one close match, and we'll get the text of that close match. And then we can be simply returning data frame, where dataframe.title is equal to title sim, and we'll be searching for the index, and then we'll simply be returning the value of that index. So then user movie index can be equal to index from title. That's the function we just made, where we pass through user movie. That's all great. Now we need to establish that similarity system, and this is where the count vectorizer and the cosine similarity come into play. So we need to instantiate that count vectorizer method. We'll store that in the CV variable. And next we need to make a count matrix. And this will make a matrix that measures the frequency of certain words in this combined features column. So it'll iterate through every movie and count the number of times certain words appears to establish a similarity rating. So we'll do cv.fitTransform, and we'll be looking at the combined features column of our data frame. Next, we can make a cosine similarity variable that then creates a similarity score based on the frequency of those words. So cosine sim is equal to cosine similarity, where we pass through our count matrix. So now we can create a list of our movies with the cosine similarity score. So let's do that right now. So we can make a variable called similar movies is equal to a list. We'll enumerate that list, and we will pass through our cosine sim variable, and it's basing that on comparing that to the user movie index. So it'll establish a similarity score for every movie in that database based on the movie that the user puts in. So now if we print similar movies and we go back to our terminal and we run our program, it should ask us, prompt us for our favorite movie. So in this example, let's just use Avengers. And then it should print every movie with its index and its similarity score to Avengers. Perfect, so there we go. So it'll print this duple for every movie. So the index of the movie and the similarity score. So we go over to our database, and let's look at the movie with an index 4802. So it's a documentary, and it's called My Date with Drew. So it makes sense that that has a similarity score of 0 compared to Avengers. But notice that these aren't in order. So we have a similarity score of 0 right there, and then 0.05, and then 0, so it's not in order. So let's make a new variable called similar movies sorted, where we call the sorted method, and we pass through similar movies, and then the key will be equal to a lambda function that looks at the second value in that tuple. So a lambda function is just an inline function that doesn't have a specific name. So instead of sorting by the index, we have 4799, 4800, 4801, 4802. It'll simply sort by the similarity score, the second value here. And then lastly, we just need to set reverse equal to true because we want to sort it from the highest similarity score to the lowest similarity score. So if you run the same program again, it'll spit out the same results, except this time it'll sort those tuples by the similarity score. So if we type in Avengers, it'll do the exact same thing. So we have a bunch of zeros down here. That's because the movies with the lowest similarity scores are now at the bottom, and as we scroll up, these similarity scores will get higher, and there we go. So it's scrolling up, and they're getting higher and higher and higher. That's all great. However, we still have only indices here. It's not super user-friendly to return a movie of 4802, would have to search through this database. So instead, we want to return the movie titles of the movies that are most similar. So let's make another helper function. We'll call it title from index. We'll pass through an index, and then we'll return the data frame, where data frame index is equal to index, except this time we'll be searching for the title, and we'll be returning the value of that. So we can make a for loop where we go for object in similar, or I guess for element in similar movies sorted. We can print the movie name. So we can call the title from index, where we pass through element and 0. And each element is that tuple that we saw earlier. So it's passing through the zero spot of that tuple. So it's passing through the movie index. So in this case, it would pass through 4802, and our function would return the movie name. But we don't want to print out 4,800 movie names, so instead we can simply cap it off at like 25. So we'll say if I is greater than 25, we'll simply break this function. So if I is greater than 25, we'll break this, and it'll only print out the names of the 25 most similar movies. So if we run this program again, it should ask us for our favorite movie. We'll say Avengers again, and it'll print out the 25 most similar movies in this database. And there we go. So it printed out Captain America, Iron Man 2, Thor, X-Men, The Incredible Hulk, Ant-Man, So it does seem to be working fairly well. All of those movies are fairly similar. So obviously this is limited to the database that we're using. I am sure there are much larger databases out there, but for the purpose of this video, our program does seem to be working very well. So I had a ton of fun making this movie recommendation system, and I would love to go into a more in-depth tutorial behind some of the mathematics and the features that we used in this recommendation system. So if this video gets over 50 likes, then I will do a more in-depth tutorial about the mathematics and some of the programming behind recommendation systems. So we can look at restaurant recommendations and some other recommendation systems later on. So if you do enjoy this video, if you did find it helpful, then please share it with your friends, give it a thumbs up. I really appreciate that. But I hope you all enjoyed, and I'll see you in the next one.